Hi everyone, my name is Ben Yu. I'm a graduate student from Arizona State University. Today's our topic is about GMS-based tools for traffic signal timing. And more specifically, we're going to talk about an open source tool called UTDF2GMNS. So first of all, it's my honor to introduce today's speakers, Dr. Milan Zakovic from the University of Wyoming, and also his student, Mutasas also Baides, who is a PhD student at the University of Wyoming, and also my professor, Dr. Sushun Zhou from the Arizona State University. So first off, just a little bit background information of the tools. So if we decompose the tools names UTDF2GMNS, it actually stands for the two data format. The first one is universal traffic data format. Is an open standard data format specification for traffic signal related data that has been promoted by Traffic Well, which is the company of the Synchro. So this is the output data format from the Synchro. So the second one is a general modeling network specification. So it's a unified data format for sharing routable road network files. And compared with UTDF, it actually covers more variety feature of transportation network model across the multiple scope. So the most important is it also contains the exhaustive traffic signal related information as well. So here's the tools that we're going to talk about today. The first one is the UTDF2GMNS. So it's based on Excel and it's derived from the Sigma X to automatically convert the UTDF dataset from Synchro into GMS data format. And the second one is the volume to timing. So it's actually a trained version of the Sigma X in the Python. So it also aims to automate the process of generating the NEMA phase-based signal control timing data. So both of these tools, the volume to timing and the Sigma X, is based on the highway capacity manual. So I also made an overall flow chart for the related tools about today's topics. On this chart from the left-hand side, so the data is coming from the OpenStreetMap, and we will use the OpenStreetMap to GMS Python tool to convert the map information into GMS data format, and it will serve as the input for the volume to timing, and the volume to timing will generate the traffic signal timing estimation result in GMS data format. And also the Sigma X can do the exact same things, which is using the GMS import-export function to convert the OpenStreetMap to GMS and generate the timing result in GMS formats. And from the right-hand side, as you guys see that the data is from the Synchro, so we're using the UTDF2GMNS convert the output from the Synchro into GMS data format. So today our topics will focus on the Sigma X and UTDF2GMNS. So with that, I will turn it over to the Dr. Zakovic and Muntasen. So Dr. Zakovic, it's your turn now.
All right, thank you for the introduction, Fan. My name is Milan Zlatkovic. I'm an assistant professor here at the University of Wyoming. And over the past several years, I have been developing an Excel-based tool for signal timing estimation. It's currently called Sigma X, which stands for Signal Modeling Application in Excel. And one of the good things about this tool, it's an open source tool. Everybody can use it. It's built in Excel, so you actually are able to follow everything step by step on how the entire process works. We have been developing these several different versions to be able to use GMNS data and then to convert from one data format into the other. So today I'm going to do a quick demo of how the UTDF to GMNS works. So I'm going to show you several different. There we go. First, I want to introduce what the UTDF format actually is and how it looks like. This is the general setting of the CSV file in UTDF format. So when you export from Synchro, this is typically what you will get. There's a couple different types of data that you can read from the UTDF file. One is the general network settings in Synchro. Then we have settings for nodes, which include node ID, includes the type of the node. Typically, the one you see with 0 is going to be the signalized nodes. It also can model other different types of control. We have X and Y coordinates. Usually, these are given in internal coordinates from Synchro. So in the new version that I'm currently working on, I'm trying to find a way how to better convert this into lat and long coordinates that can be used with GIS software. And we also have settings for nodes, for links first. In this case, again, for each node, we have information about the incoming links, outgoing links from each approach, which are based on like east, west, north, and south. Information about grades, information about the curves, everything that can be important for analysis. Then we also have the information about each lane for each node. So for example, if you're looking into the signalized nodes, we have exactly information about every single movement. So is it going to be a left turn movement, through movement, right movement? Sometimes we may have a U-turn movements or anything like that. And then it will give you the some information and coding about the incoming node, outgoing node, number of lanes. Is it a shared lane or not? The width of the lane, and so on and so on. We also have information about the approach speed. And then we have information about the signal phasing parameters. So when sigma X reads this, it doesn't perform any internal optimization or anything like that. It simply just reads phases given in the UTDF format. And then we also have the information about, it's a little bit big file, about phases. Now, this is an interesting one. So this might actually be a little bit helpful to understand what this one means. BRP stands for barrier, ring, and position. This is a standard NEMA ring barrier format. In this particular format, usually what you have, and I can kind of show you real quick. We have something like this. So we have, let's say, ring 1, we have ring 2. And then on this side, we may have a barrier. So for example, and I'm gonna kind of visual this real quick so you can understand what this one is. So this is the ring barrier structure. Sorry, I don't need this one here. So in this ring, typically the way the NEMA phasing looks like is the number of phases given by ring and by barrier. And it looks like this: 1, 2, 3, and 4. So these are phases 1, 2, 3, and 4. In ring 1 and then ring 2, you have 5, 6, 7, 8. So if you look into this particular information given here, BRP, what does 1, 1, 1 means? It means it's barrier 1. So this is going to be on this side, this is barrier 1. On the left side, on the right side, it's going to be barrier 2. And again, I can just visualize this a little bit. So we have barrier 1, and then we have barrier 2. So 1, 1, 1 means it's going to be barrier 1, ring 1, position 1. So my phase number 2 in this case, so these are the numbers of phases. If I read this from the Synchro file, it means that my phase 2 is going to be at this particular position. And again, so this is NEMA standard, and I'm going to show you how to read this one. I know we had a lot of discussions earlier about sequencing and staging, so this is why I want to kind of explain this a little bit better. So again, these are the phase numbers. We have phases 1 through 8. Maximum phase number of phases you can use in a signal controller is 16, but usually you're not going to see this except if you have some kind of complex design for intersections or some special signal operations. So I'm reading my phase number 2. It says it's in barrier 1, ring 1, position 1. So my phase number 2 is going to be here. Then I don't have anything for phase number 3. I have phase number 4. It says it's going to be barrier 2, ring 1, position 1. Here's where my phase number 4 is going to go. The next one is phase number 6. It says barrier 1, ring 2. So the second number here shows you the ring. Position 1, so this is where my phase 6 is going to go. And then this one says 2 to 1, which means barrier 2, ring 2, position 1. So this is kind of coding how to create this ring barrier structure for each of these intersections. And we can kind of do another one. Let's see which one would be that has a little bit more phase. For example, this one here. Let's try this one. So it's exactly going to be the same approach. Now this one has phases. This is phase 1, 2, 3, 4, 5, 6, 7, and 8. So phase 1 is 1, 1, 1, which is here. Phase number 2 is 1, 1, 2. So barrier 1, ring 1, position 2. Here's my phase number 2. My phase number 3 is this one here, 2, 1, 1. So barrier 2, ring 1, position 1. So my phase number 3. And then this is my phase number 4, 2, 1, 2. So barrier 2, ring 1, position 2. So hopefully now you understand how this works. Now sometimes you might see a little bit different. For example, we may have, this is what we call leading left turns. Sometimes we may have leading through movements. But this is the way how you read the codes from here. And that's something that I just wanted to explain a little bit better, just because a lot of times we kind of come into a problem where we want to decide how the sequencing works. All right, so now that we know how this looks like, I'm going to go and show you a different tool. So I'm going to open these two files simultaneously, and then first I'm going to explain you how the import process works. All right, I probably need to clean this one, and then I'm going to share my screen here again. So this is my Sigma X file. In this case, it's optimized, or it's actually being upgraded just to read UTDF files. So if you look closely, this is exactly the same graphical user interface as we have in our typical Sigma X applications. But what this one is doing first, with the help of some VBA codes, first what I do is reading the UTDF file, and I put this in this separate tab. Once I have this separate tab with my data in here, so let's say if I paste my data from the UTDF file, then I need to first determine what are going to be my signalized nodes. And then this is again my simple code that reads all of those data sets separately. So for example, as I told you before, we have nodes, links, lanes, phasing, and then this is how it reads all of those separately. I'm going to show you the code later. So currently I do have some numbers in here, but everything is automated, so you actually don't need to do anything manually. So once I have all this information, then I separate all of my inputs in separate tabs. So I have input for links, for lanes, for time plans, and for phases. And then this is something that I use to export my GMNS format, as well as the timing or simulation timing, the way we call it in here. So to do that, we have another control application, which now I'm going to show you as well. So this is my control application. If you look closely, it's a very, very simple one. But what it does, it actually has a bunch of codes that are doing all the work behind the scenes. So what it does, it's going to open the UTDF file. It will put it into this Sigma X file. And then once I have that file in place, it's going to go through each signalized intersection, read the data, and then export the data back into the proper formats. Now, another thing that we need to do is to prepare the data. And I'm going to show you how to do that as well. So I need to share my folder in here so that now you can see what I'm going to do. So if I have, for example, we can do an example with two files that I have. One is SR85, the other one is Bell Avenue. So first, again, this was the one that I had before. What I need to do is to rename this one. So I'm going to make a copy. And I simply just need to rename this one in UTDF8, like this. So UTDF8. It's going to be a CSV file as well. And then I do have some extra data in here that might be confusing. I'm just going to get rid of that. So once I have this renamed, this is going to be my input. And then let's go back again to my UTDF2GMNS tool. Now, all I need to do is just to start my program. Now, this might take a little longer because first, Excel is a little bit slow and it needs to go back and forth between a couple different input files. The way it works, again, first, it will just filter out all the signalized nodes, and then it will start reading them one by one. For each signalized node, it will create a separate SigmaX file with a corresponding name, and I'm going to show you those as well. And it will also create several types of CSV files in the GMNS format. So, for example, timing, phasing, signal concurrency, phase concurrency, signal timing phases as well. Can we remember all the names? But there's quite a few of those files that will be created automatically, and then you can just use them. If you have any other type of software that you want to read this into, you can simply use those GMNS files, and it will automatically read everything for you. All right. So now this is done. I can close this one. And then let's go back to the folder and take a look what we have here. Now, if you look closely, these are my SigmaX files for each node, signalized node that was read from this file. There's 20 in this particular network, and you can easily check that if you open up the UTDF file. You can just filter out nodes that have 0 as the traffic control code, and you will see there's 20 of them. So these are all of our signalized intersections along the chord. We can open any of these. So I'm opening one now. Let's see. Looks like it's still opening. Just give me a second here. Okay, there we go. So this is one of the nodes, for example. Now, if I go back to my input, this is the input that was automatically read from the UTDF file, including the geometry, number of lanes, pedestrian volumes or bike volumes. So again, if you have those in the UTDF file, they will be read and they will exist here. The names of the streets as well. And then also we have the node number. So all this information is being fed into the SigmaX. Then you can also look, for example, all the phasing. So remember when I was telling you about this particular format, so it will read all those phases. In this case, depending on the type of the intersection, we only have 2 phases that are being used. If we go to my summary, I can again see my turning volumes. As you can see, this is just an intersection that's using 2 phases, and these are the 2 phases. So phase 1 is for east and west approaches. Phase 2 is for north and south approaches. And then it will give you, the cycle length. You can read the offset as well. So if you go to my phase calculation here, here's my offset. In this case, there's no offset for this intersection, the reference intersection as well, if it exists in the UTDF file. You can read your split summations. You can read the movement capacities. Now, one thing about the movement capacities and control delay V over C ratio, since that information does not exist in the UTDF file. So all the performance measures are actually output from sigma X. So if you compare this, if you open up the same network in Syncro and then you compare some of the capacities, delays, level of service, you may not see exactly the same numbers, just because that information is not included in the UTDF file. And then the sigma X tool actually does all the performance measures. You can see the phasing chart again, since we're just using two phases. You can show you the green time, yellow time. If you have any red time, apparently this is like maybe 1 second of all red time. What are the kind of designation for phases? And then this is the input that I'm actually using to read into my GMNS format. And that's the next thing I'm going to show you. So you have these files for each intersection separately. Now let's look into some of the outputs in the GMNS format. So for example, this is the signal timing plan in Excel. If you look closely, we have again 20 intersections. Then we have the timing plan ID. In this case, it's all one. The time of day. So currently for this particular plan, it goes from midnight to 3 p.m. The cycle length for each intersection. As you can see, this is a coordinated corridor. 120 seconds is the cycle. With the exception of this one, sometimes we allow what we call half cycle. If in the coordinate system, if we don't have enough traffic demand, if it's a small intersection, for example, you can use half cycles as well. The reference for coordinated phases, and then also what is the offset for each intersection. And we can look into some others. I'm not going to show you all of this, but let's look into the simulation timing file. Again, this is all the information that's being read from Syncro UTDF, and then exported to GMNS format. So if you look into my nodes, as you can see, this is given by node. So this is my node number 3. I do have the capacity of movement, volume to capacity, cycle length. I have the green time, red time, stage number. Again, this is that little ring barrier structure that's being converted into stages for the GMNS format. The movement code, and then we also have information about the start and end of the green time. Now this format might be a little bit, because it's a CSV, so it should be in this format with the zeros. So that's one thing I'm still trying to figure out, because it's not giving me this particular format. So this should be like 0, 0, 0, 0, 0, and this should be 0, 0, 0. 1 to 1 means 1 minute and 21 seconds when it's changing. So this is how the process works. Again, we do have several different files in here. So you can look through all of this, all of them in the CSV format, and then all of them follow the structure that we have in the typical GMNS format. So this is the quick overview of how the UTDF2GMNS tool works. Relatively quickly, I'm working on some updates, some more functionalities in there. So next thing that we're trying to do is create a node file and link file with exact coordinates for each of the node, and then maybe providing some information for each of the node in maybe like a KML file, and then you can open up Google Earth, and then you can see the information about your intersection in a very user-friendly tool. But once you have the coordinates, then you can also use, for example, QGIS tools, any type of GIS tool that can work with coordinate systems. So hopefully, with this type of tools, we're going to have pretty powerful tools to do all this kind of analysis, conversion between different formats, and so on. All right, so that was my demo on how the UTDF tool works, and I'm open for any questions or any comments if you guys might have.
Thank you very much. I think I have a question for that. So you mentioned that the UTDF2GMNS it just convert the data from UTF, but it doesn't have like timing information, right? So the sigma S also continue do the timing estimation for the traffic signal, right?
No, so everything that has to do with phasing or timing, so for example, green durations, blue durations, yellows, red clearances, all that information is being passed from Synchro. So SigmaX doesn't do any of those computation. The only computation SigmaX is doing in this case is the performance measures. For example, delays, level of service, capacities, volume to capacity ratio. So that's the only information that is not included in the UTDF file, and that's what SigmaX is producing as an output. Everything else that has to do with signals, with phasing, timing, offsets, all of that is being read directly from the UTDF file.
Okay, thank you very much. So actually, I really like the Sigmas when I first try the software. So compared with volume to timing, so because it's based on the Excel, so it has a better visualization for the result about the timing, like timing bar chart and the phase destination. So for volume to timing, so it just comes with the GMS data set. So that's the reason I make video to use QGIS to visualize the result. But for the Sigma S, it's more directly we can see the how the result looks like. So thank you very much for your work. Thank you.
Thank you.
Thank you.
Thank you.